All right, I think we're going to get started. First of all, wow, we are so excited to have all of you here today. It's really amazing to see the women in product community come out in full force. We sold out tonight's event, so we're really, really excited that you guys could all be with us today. By way of introduction, my name is Prerna Singh. I'm a senior product manager at Mashable, where I lead the development of all of our data products. I'm also one of the organizers for tonight's event, and we couldn't be more thrilled for all of you guys to join us as we launch our first Women in Product event here in New York City. For those of you that are part of the Women in Product Facebook group, you're probably pretty aware that a lot of the events that we host are in the Bay Area. And so tonight's the first night that we are kicking off in New York City. So again, really excited for you guys to join us and show us your support. Before we go any further tonight, though, I do want to take the time to thank our corporate sponsor, Squarespace, for allowing us to use this beautiful space that they have and for allowing us to come together as a community. So thank you to Inga and the events team and Squarespace product managers that have been helping everyone out tonight. So I think we should give them a big round of applause. We have a really great night of conversations and discussions ahead of us, thanks to all of our panelists that are here tonight. But before we jump into that, I wanted to take a few minutes just to talk a little bit about women in product and what our mission is. So Women in Product started a little under a year ago, actually, and it started off with a group of women product leaders in the Bay Area who kind of realized that there was an opportunity, well, rather a gap in sort of having product managers, female product managers, kind of come together and be able to sort of share their experiences. And so they kind of came together and built a Facebook community, first off, that allows sort of women product managers to come together, share their experiences, and just leverage each other's experiences to grow and empower each other. So that's really reflected in the Women in Product mission that you see here on the screen. So we're all product managers, so what's a slide without some data? And so just wanted to kind of show the growth of women in product in just about a year. So since we started about a year ago, we've grown this Facebook community to over 4,200 active members, which is really, really amazing. And it's an amazing community. If you aren't part of it already, I'd highly, highly recommend that you join because of the conversations are really amazing, and I learn something new every single day. We also have 4,800 email subscribers. This is our weekly newsletter that's hand-curated by women product leaders. So there's a lot of great resources. There's also job drops. So those are specifically curated for the women in product community. So highly, highly recommend that you sign up for that newsletter. We've hosted 17 events in 2017 to date, tonight being one of them. And this is, I think, just to kind of show the momentum of this community. Most of those events have been in the Bay Area, but as I mentioned earlier, we're really looking to sort of expand to other markets, obviously New York being one of them. We just had an event in Seattle earlier this week, and we're looking to kind of go globally as well. So lots of really great momentum. And then the marquee sort of event for Women in Product is the annual conference. So last year, we had our first annual conference out in the Bay Area, and we had women product managers from around the world come and attend. And obviously, I think one of the biggest sort of metrics, I think, as product managers, we look for is how likely would you be to recommend a product. So thinking of this conference as a product, we had almost everybody say that they would recommend this conference to their peers. So we see this as a really great sign of the momentum that Women in Product has. So speaking of momentum, obviously we want to talk a little bit about how do we keep the momentum going, not just at this event, but as you guys leave, how can you be involved? So definitely join the talk. As I mentioned, the Facebook community is a pretty vibrant one. Lots of great conversations, people sort of helping out one another, and lots of sort of experience that's shared across the board. So there's the link to the Facebook group. As I mentioned earlier, there's an annual conference. Our annual conference this year is coming up on September 19th in San Jose. So it's out in the Bay Area. But it's a day-long conference, a lot of great panelists, and lots of great sort of conversations there. So definitely register. We're close to selling out there as well. We have about 1,000 attendees expected to attend. So it's going to be a really great conversation. So tickets are available at womenpm.org. And then lastly, if you want to be involved, please reach out to me or any one of the organizers. Inga and Maria's over there in the corner. We would love for more people to be involved in this movement. So if you're interested in hosting an event like this, or your company's interested in sponsoring, definitely feel free to reach out to us. I'd be remiss by not sort of pointing out that there are men in the room, which is amazing to see, as we need all the allies that we can get as we spread sort of the mission of women in products. So if you're a guy, definitely please follow us on Facebook and Twitter and all sort of the different social media accounts. Consider hiring from this really amazing community. That's kind of the way that we're going to get sort of the women in product mission out there. So without further ado, I'm going to kick off tonight's talk with Inga, who is a product manager here at Squarespace in analytics. And she's going to give a lightning talk on what it means to build machine learning products at Squarespace. All right.
Thanks so much for the introduction, Prerna. Just wanted to say again on behalf of Squarespace how excited we are to be hosting Women in Product's first New York City event, and to kind of bring together so many different women in product managers, women product leaders, as well as our male allies. So thank you again for coming. So I just wanted to give a quick overview, kind of lay of the land about machine learning from a product perspective. I think in attending a lot of different machine learning events, I think a perspective that's kind of missing is that there's a lot of focus on algorithms and a little bit less on like the holistic picture of how would you build a machine learning product. So goals for this event, hopefully you've already met and heard from your fellow product managers in machine learning, hopefully get you even more excited about machine learning, and then consider using machine learning in your products. So it's not for every problem, but it's killer for the ones that it's good at. So that's the goal of the event. And then quick agenda for this talk. Concepts of machine learning for product managers, just so we have a shared language going into the panel of the amazing 5 speakers that we have. And then look at how we think about product development for machine learning at Squarespace. And again, that's not meant to be prescriptive at all, just kind of how we think about it to give you an idea, and then talk about the hype of machine learning and whether that's real or not. So before Squarespace, I worked at Automatic. So just a little background about me. It was a connected car startup in San Francisco. And most people knew us as a car hardware and software startup. But we thought of ourselves as a data company. So we were solving a problem for drivers. And people spend a lot of money on gas and maintenance for their cars, if you own a car. Unlike New York City. And so we were sitting on lots of data about people's driving habits and behaviors. So that was a pretty interesting data and machine learning problem. And then at Squarespace, it's an even larger scale. So we have millions of websites that are created on Squarespace. You can think of it essentially as a slice of the internet. It's as diverse as the internet. And so we're trying to help small, medium-sized businesses make better decisions about creating and maintaining their online presence and business. So when you have that much data, machine learning is really good for creating an optimized experience for each user. So kind of in contrast to creating kind of a blanket rule or blanket product experience, we're able to say all of the data that we know about you as a specific user, like you, Inga, you, Ronnie, for example, you can get a unique experience for you. So what is machine learning? Quick definitions. Machine learning is a subset of artificial intelligence, a really loaded term, but just basically human intelligence exhibited by machines. And you can categorize kind of intellectual tasks that a human can do into these buckets, and then you can say these are the goals of AI. So we would want an AI to be able to reason, to accumulate knowledge, to plan, to perceive, to move and manipulate objects. But it turns out that learning has kind of subsumed the other goals of AI, because if you can learn, then you can learn to reason, you can learn to perceive, you can learn to understand language. So one of my favorite definitions of machine learning goes back to Arthur Samuel from 1959. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And I think that last part is particularly interesting. Learning without being explicitly programmed means you don't have to tell and be very, very specific about how a machine learning model is going to learn about a concept. You kind of set the parameters, and then it goes off on its own, and then you figure out what it did. But I would add to this definition with a few caveats. So by observing data, that's kind of how it learns. It looks at a bunch of data, often more data than is humanly possible. So I think that's interesting. And then makes a determination or prediction about something in the world. So how does that work? At its core, machine learning, I like to think about it as a set of inputs and outputs, and your machine learning model is in the middle. So a really basic example is Gmail's spam filter. So you have an email, that's your input, and then it tells you, I think this email is spam or is not. So you start with a lot of data. This is how it learns. So you have a bunch of emails. Ideally, your data set is labeled. So what labeled means is, in this case, an email is labeled as spam or not spam. And you might get this manually. You might seed it organically from your internal company. And then I like to think of splitting your data set into two parts. And I like to think of it as similar to how we learn as humans in school. So when a teacher gives a lecture, for example, they give a bunch of examples to illustrate a concept. And then the way you test whether you understood those concepts is you give it problems that it's never seen, or you give a person a problem they've never seen before. And so that's similar to how you train a machine learning model, is you split your data set of labeled answers into two, you show them a bunch of examples, and then you test if they've actually learned that concept by giving it problems it's never seen before. But you actually have the answer, so you can see how accurate it's being. So back to our diagram, I think what's interesting is that machine learning can seem like a black box, but we as product managers, we as like the internal people working on the machine learning model, can have like accuracy and see the confidence level in which the model is predicting things. So even though it might be a little hard to figure out what exactly it's doing in the model, you can get a really clear picture of the accuracy before you even ship anything. So what we just talked about was a form of supervised learning. So supervised learning is basically when you give answers or give examples to a machine learning model. It learns from those, and then you hope that it can generalize to problems it's never seen before. So since we're all product managers, I like to frame things in the context of problems. So say you want to identify objects in billions of photos, and that's basically what Google image search does. So back to our diagram. So say you had a bunch of images of really cute animals, and you wanted to identify which of those had cats, and you wanted to do it not just in these 5 photos, but you wanted to do it in billions of photos. So this is your small kind of training set. And then you train the model and you're like, okay, let's see how that performs. So these are all unseen data. So very cute animals, but the machine learning model has never seen it before. We'll see how well it works. So what's interesting about this is once you test it, you can get a prediction level and a confidence level, so you can really assess the accuracy. So basically, the machine learning model says, this is a cat. The hippo is not a cat. That's pretty clear. But then it predicts that Boo, the dog, which is a very famous dog, one of my favorite dogs, is a cat. And so that, for example, is an error in the model. And so you have both false positives and false negatives. And then you get to basically an accuracy score that's called F-score. And that's how you kind of evaluate how well your model is performing on data it's never seen before. So you do all of this before you even ship the model. And so that's back to my point of machine learning seems like a black box, but you're able to see how it can perform in the field even before you ship it. So that's supervised learning. Unsupervised learning, by contrast, is there are no answers. It tries to find patterns in lots of data, and then you kind of have to go and figure out what happened or what it did. So back at Automatic, we wanted to tell users how they could improve their fuel efficiency based on how they specifically drove. So not just here like your top 10 tips of how to increase fuel efficiency, but based on the car that you drive and based on all of your driving history with Automatic, how can you improve? Or can you even improve? Is it hopeless for you? So this is just an illustrative example of a bunch of driver fingerprints, as we call them, driver profiles of your data. So all of the hard brakes that you did, all of the hard accelerations that you did, this is actually my own driver fingerprint. And so we used an unsupervised learning algorithm called clustering, and we said, okay, can you please divide all of these profiles into 8 clusters or 8 groups? So it did that, and then we have to go back and figure out what distinguishes those 8 clusters. So for us, that was answering the question, essentially, what are the biggest factors affecting fuel efficiency of drivers? And once we have that, we can say, if you manipulate this one factor, then you can increase your MPG by X. So it turns out for us, or for our user base, the 3 biggest factors were aggression on the highway, impatience on local roads, and external factors, so weather, traffic, terrain. So if you're a pretty aggressive driver, you can potentially blame it on local conditions. So again, from a product perspective, we took those 8 clusters and we just named them in kind of memorable icon personas so that we could easily explain to our users who weren't data nerds what kind of personality driver they were. And so this was kind of the output. So we gave you both your persona. This is also my own profile as a suburban scout. And then you can see your driver fingerprint. And so we took those 3 factors and we made sliders out of them. And so say you wanted to see how much worse would my MPG be if I just ratcheted up my aggression on the highway. And if it didn't really affect it, then maybe I can do that more often. So the point that I wanted to drive home here is just that you can personalize insights for each user. And so I think that's one of the really exciting things about machine learning for me. And then deep learning. So deep learning is probably the most exciting thing or subfield of machine learning. And for our purposes here, we can kind of use deep learning and neural networks interchangeably. So I really like this diagram by Michael Copeland because it basically illustrates that AI has been around for a really long time. Machine learning is a bit newer, but deep learning is really, over the past few years, has it really driven machine learning into the mainstream. So one other problem, so at Squarespace, we have millions of websites. And so for us, with our millions of websites, how do you become familiar with all of your different customer segments? How would you even go about categorizing your websites into verticals? So the machine learning team decided to build a visual search engine for websites. So this is one of our Squarespace customers. And so this is a vastly oversimplified diagram of deep learning, but I think the key concept here is just that deep learning is deep because it has many different hidden layers, and you can think of hidden layers as like layers of transformation. And so in this example, you feed the machine learning model a bunch of images of websites. And then maybe in the first or second layer, it says, okay, I can identify that maybe a face is around circle or around oval. And then in the second or third or fourth layer, it says, okay, I'm now seeing that 2 circles within that oval means an eye, and then they kind of piece together the face. And then you kind of restrict that data into a much smaller piece, and then you ask the model, okay, using this smaller piece, can you recreate the image that you just derived this from? So you do this not a billion times, but you do this many times, and eventually it learns how to interpret the structure of the image, which I think is pretty interesting. It's not just that it's comparing pixels, it's actually learning structures within images, and then you can find similarities to that website, for example. So this is basically what that model returned. So you can see that they're all faces to us, and that's very obvious. We'd be able to pick that out. But you can see there's also like some interesting errors as well. So that the one on the right is clearly not a face, but maybe the model thought that those look like eyes and maybe a mouth. So onto building machine learning products. I think it's worth noting that products in practice are usually multiple machine learning models stringed together. So say you wanted to implement something like Alexa. Alexa, turn on the lights. I do this every night. This would probably be multiple deep learning models. So maybe one deep learning model that's turning your voice into text, and then maybe another deep learning model that's turning text into tasks or commands to actually turn on the light. And then one of my favorite examples is Spotify Discover Weekly. And this is I think this quote really it captures the magic of machine learning. Is I wish my significant other understood me as well as Discover Weekly, and you can imagine why. Like, Spotify knows all the songs that you listen to at any time of the day. They can probably predict what you would want to listen to next. So again, this is multiple deep learning models, just contrived, but probably one that's interpreting audio. And another one that's looking at all of your listening history and all of your preferences to create this picture that they can create a playlist for you. So just wanted to highlight that. So in terms of how we think about developing products at Squarespace, again, this is not meant to be prescriptive, is just how we think about developing machine learning products here. So this is a pretty simple kind of product development cycle. So PMs learn about a problem, you prioritize the problem, you build the solution, you launch it, and then you measure it. So some considerations for machine learning. It's probably around this stage that we classify a problem as really good for machine learning, and we always make sure that we consider the non-machine learning potential. And then during prioritization, there's always gathering and preparing data. This often can take way longer than your build process. You might even have to make some product changes to gather better data. Maybe you don't have a lot. You might have to bootstrap some data and label it yourselves. I had to do that. I got my entire team to label. And then build and evaluate models. And so this is a lot of trial and error. You try a bunch of different algorithms. You might even have to throw some away. They're not as accurate. They're not shippable, things like that. So eventually you launch your production model. And what's exciting here is that you can know even before you launch that there's some level of accuracy that you can expect to achieve. And then measure. And then you can identify model weaknesses. So I think it's worth noting that sometimes you just launch to collect more data. And that's kind of the point of launching. And then you go back and iterate and you build more models and better models. So a bit of a tangent, but kind of our org structure at Squarespace, because I'm always curious to hear how other people are structured. But for us, our machine learning team is 5 strong. 1 team lead, 3 engineers, and an intern. And then our product team is 2 directors and 11 product managers and 1 UX researcher. And because we are a women in product meetup, I just wanted to highlight or brag that I personally can't believe that we're 40% women on the machine learning engineering team and 57% women on our product team, which I'm super, super proud of. So just to conclude, why machine learning now? The first major trend, kind of maturing of machine learning algorithms, particularly deep learning and the plethora of open source tools, has really democratized the landscape. Massive compute power that we've never had before, so GPU processing and cloud computation. And then not just lots of data, not just big data, but accessibility of open data. And so Common Crawl and ImageNet are just 2 examples of ways that are really, really accessible for anyone. And so ImageNet is like 14 million labeled data images. So I think that's, so what this means for you, maturing of machine learning algorithms, your competitors are probably doing it. So you should at least consider it for your product area. Massive compute power means it's not just for big companies now, it's not just for the Googles of the world, startups are doing it too. And then the accessibility of open data means that even individuals can build machine learning models on their own. So that's all I had. Would love to continue the conversation. Find me on Twitter or email. And now we're going to transition to the panel. Thanks, everyone. Cool. I'll start off by introducing our amazing panelists. We have 5 of them. And it looks like we have more mics. Cool. So Amy on the rightmost, or leftmost rather for you guys. Amy is a senior product manager at Clarifai, a machine learning computer vision platform for developers and enterprises. Prior to Clarifai, Amy founded an early stage startup called Miscellaneous Mischief, where she built 7 consumer-facing products, including Toothpick, Wingman, and Squad. Amy started her career in investment banking at Deutsche Bank. Sarah Catanzaro is an investor at Canvas Ventures, where she focuses on analytics, data infrastructure, and machine intelligence. Before Canvas, Sarah led the data team at Mattermark and was a consultant at Palantir. Ronnie Falcon is a product manager at Google Local Discovery. Previously, she developed data-centered products like Google or YouTube Analytics and is a graduate of the APM program at Google. Welcome, Ronnie. Carla Kochalski is a senior product manager of intelligent assistants at Capital One, where she leads the team responsible for building Eno, the first SMS-based chatbot launched by a US bank. Previously, she led digital and social media strategy for Samsung Mobile USA and has an MBA from Georgetown. Elsie is a senior product manager at Nara, an AI platform company. Previously, Elsie was a researcher at Harvard Business School, co-authoring several cases. So if we could all give a big round of applause to our panelists. Thanks so much. When we were first assembling this panel, I was unsure we would get so many amazing women product leaders in machine learning interested in speaking in New York City. Quite a narrowing of that. But we got 5 panelists, so super excited. So we're going to structure our panel by walking through the various stages of the product development cycle. And then we'll look at the future of ML and ponder on how we can bring more women and diversity into machine learning. And then we'll close with some actionable ways to learn more and get involved. So kind of background first. So can everyone kind of tell us the story of how you got interested in machine learning in the first place?
I'll start. Great. So I'm Elsie, and as Inga said previously, before my role at Nara, I was working in business research and was focused on how intermediaries, particularly in the creative industries, help spread information and help enterprises grow and industries grow. I became particularly interested in how technology can help with knowledge sharing and spreading. I ended up joining Nara when it was in the R&D phase, where the team was focused on applying research that came out of MIT neuroscience, in the neuroscience lab, on connecting information just as the brain connects information. And so that was really my introduction, and it continues to be a big passion of mine, of connecting knowledge within organizations and across industries.
I'm Carla, and before I joined Team Eno, I spent the majority of my career building experiences within social and digital. So my passion has always been to leverage new technology and build experiences that fit within our customers' lives. So at Capital One, when I first started, I actually created the team that services our customers through these channels, Twitter, Facebook, and I also led our social intelligence arm, where I got my first taste of machine learning with some of the social tools that leverage natural language processing. And so my passion has always been, hey, there's this new technology out there. How can we create and build products for our customers and where our customers are? And so the opportunity arose to lead this product in our intelligent assistance team, and so I jumped on it.
Hi everyone. So I'm Ronnie. My journey with machine learning started at university. I studied computer science and learned how to program a bunch of those algorithms, so that was fun. Did not pursue intentionally a machine learning career, but working at Google, as the company moves more and more towards machine learning focused, this is part of our new way of thinking about products and problems. You kind of have it everywhere. So encountered a bunch of products and problems that we decided to solve with machine learning, and through that I got a bunch of experience working on that. So lucky me.
Hi, Sarah, Catanzaro. So I think I'm a little bit unusual in that I started with machine learning, later went into product. I began my career in the defense and intelligence industry, where we were using machine learning to really model adversary behavior, to understand how insurgents or pirates might respond to US military actions in certain events. I subsequently realized that I was not going to solve warfare or terrorism or something like that, wanted kind of more pragmatic experience, and realized that we could use the same technology to build better products. And now as an investor, I get to work with amazing teams who are doing just that.
Hi, I'm Amy. So everyone has really great answers on how they stumble or became curious about machine learning. So my interest in machine learning was pretty recent, but it's always been in the back of my mind. I always like to understand things from sort of high level, and the way I view, and given my background, and I started in finance and sort of started working on building on my own consumer products and really, honing in the user experiences, and it was mostly mobile apps at the time. And the way that I look at sort of the technology and the industry trend is that before, way back, like before the internet age, the way that information would be exchanged in this earth would be through print, through paper and language. And it's sort of evolved into, okay, now we have this thing called internet, and you're no longer sort of bound by close like distance proximity, and people can now exchange information across the globe, you know, in the minutes or seconds. And then after that, so information became really, really easy to access, but it was still sort of confined to like your interaction with the computer, which was a desktop. You know, at the time we had a dial-up, right? And then now sort of came mobile, which was sort of the industry that I was working in at the time, and it sort of opened up so many interaction points and access in basically devices that could start collecting all this data that just wasn't available before. And I was so curious, where is this industry heading, right? What are we gonna do with all this data, right? Like, sure, people start like measuring all these data points, all the user interactions, and I stumbled upon Clarifai at the time. I left sort of the startup that we got acqui-hired into, and I wanted to sort of work on something more technical, sort of get back into more of my math side of the brain. I majored in math, and realized that Clarifai, here's this awesome founder/CEO who was essentially tackling on the problem of, we have so much visual content. I came up with this cool algorithm that could essentially classify all the images that people can feed into. And let's make a really great platform where all the users, even if you have 5 images, you can come to us and build a machine learning model by yourself, you know, as easy as seconds, and sort of open up that access point of machine learning to everyone for especially computer vision needs. And that's a long roundabout about answer for sort of connecting my dots and figuring this is a really great opportunity, let me hop on it and join his team. And I've been there since.
Awesome, wonderful, so inspiring. So if we could go quickly over kind of describing your products and then what kind of machine learning they use, that'd be great.
Great. So Nara is an AI platform company for enterprise app developers. We power mostly recommendation and decision support applications. Our technology is a new form of AI that really is focused on applying the brain's connection mathematics to data. So we take in customers' data and we build knowledge graphs that are weighted based on the different types of information within the inputs. Those graphs are then indexed for real-time retrieval, and we have APIs that application developers use to build their applications. So any sort of user recommendation problem where a user likes a set of items or has a certain set of preferences, we can retrieve the information from within the company's graph for that specific use case. We also have built interpretability into the product as a key feature, because we have this explicit connective network. We can trace back through the result of any recommendation that we give, so it helps the user understand.
So my product is Eno, our first SMS chatbot. And the machine learning that we use is several deep learning models, including natural language processing. A lot of it well, actually all of it mostly is supervised learning, where we are taking the conversations customers are having with Eno and trying to understand what they're looking for. So the value of Eno is that you can get the information that you need about your money and your accounts by simply sending a text, and Eno understands the natural language that you want to use with banking. And by the way, it also understands emojis. So we are trying to solve this very interesting problem of the new language that is emoji that most people use in texting. How can we actually apply that to something like what's my balance? And so far we are now able to understand, I think, more than 1,000 ways customers ask for their balance. So it's pretty cool.
So I work on local search and discovery. This basically means when you search for a place on search, we give you information about that place or help you find places under that category. So specifically, you search for per se restaurant, and we give you the information card with the photos and the addresses and all of that, and reviews, etc. This product basically has machine learning in so many places and parts. You can imagine that this product needs to work in scale, not only just the places in the US, but in the world, in different languages and different cultures. So we leverage a lot of machine learning systems and ways to basically be able to do that. 2 examples to make it concrete. You want to browse the photos of the restaurant to get a sense if it's good for your next date night. We can now classify whether a photo is an interior view of the restaurant or exterior. Is it a food photo or not? So that's a very simple example of machine learning in our product. The second one is that we're trying to classify attributes about the place. So we're trying to say, hey, is this place romantic? Is this chic? Hip. Google classifies hip to places. So we are basically leveraging a lot of web content and images, and as well as real user votes. If you've ever received a question from us, hey, is this place good for cocktails? This is what it's powering. It's basically, we're trying to learn what are the signals that are relevant to classify great for cocktails, hip, or chic. So a bunch of products that leverage that.
So I'm a VC, not a PM anymore, but our product, I'd say, it's our portfolio companies. And in that vein, I get to plug them. So, our most recent investment was in Kinetica. It's a GPU-accelerated database that allows you to run your ML and BI workloads simultaneously. We're also invested in Crowdflower, which can be used to generate and really amplify training data.
And real quick, I know Sarah led and started the data team at Mattermark, so it'd be great if you could kind of touch on some of the work you did there.
Sure, and I keep passing you this mic. I am so sorry. So at Mattermark, we used machine learning to really structure the world's business information. There's a lot of information about private companies that is siloed in different places. But there's also kind of institutional knowledge, like what a B2B or B2C company is. That's difficult to apply to this knowledge, which is not integrated and at scale. So we used machine learning, for example, for industry tagging or business model tagging. We also used machine learning to power semantic search, really with the goal of enabling both investors, salespeople, and corporate development folks to find and access information on corporations with whom they want to develop a relationship.
So at Clarifai, our product is actually the machine learning technology itself. And the way we define our product is creating a platform around it so that any user on our platform, which are usually developers, can access the technology, the model. Now, after Inga's presentation, everyone can speak the same language. The model that our founder has built, which is our sort of bread and butter general model, more easily, fast, efficiently, and effectively via API. And on top of the general model, ever since we've launched, we've built a lot of domain public models, such as food model, wedding model, travel model, which essentially the output taxonomy is very much catered to those industries. So food will look at scallops and garlic, whereas general model will just recognize food in a model, or maybe as defined as pizza. Since people like pizza. And on top of that, we realized that a lot of our customers who are businesses who want to really tackle on their machine learning needs, and maybe they thought they want to really be able to customize the taxonomy, right? So you want to be able to say Amy's dog, Bob, and instead of just saying a plain old dog returned to you after passing in the pictures. So what we've also created since then is this custom training model product where you can define your own taxonomy, with as little as 5 pictures. You can come onto our platform and start your own Amy's model and define your own concepts such as Bob and Joe. The model itself will be trained based on sort of the tech that we currently have, so that you wouldn't need to start from sort of ground zero of building your own model from, say, TensorFlow or your own framework. Bulk majority of sort of the setup work has already been done for you, and so you can get going and up very fast.
Awesome. So I think it'd be interesting to hear kind of, were any of you afraid of anything, or concept-wise or skill-wise, when you first got into machine learning? And then what has since surprised you now that you've been in the industry for a while? Did I stump everyone?
I'd say in terms of things that both frightened me and surprised me, managing machine learning teams in the context of an organization can be really difficult. There's no predefined formula for how to kind of cultivate data scientists, how to work with other divisions within your company. And so it still remains today, I'd say, one of the biggest challenges associated with both management and product. Like, where does this fit in, and how do you grow the people who are required to kind of make use of this new technology?
I'd say that one surprise was just the critical importance of data management and processing. You can't really have an AI or machine learning product unless you have that piece, unless you've thought about how you're going to update your model, how you're going to learn over time, and how things are going to change. So if you talk with any data scientist, they'll talk about the amount of time during their day they spend cleaning data. So if you have a product or a pipeline that can do that, you're really helping yourself move faster in the future. I think also thinking about the application side, you have data coming in from a lot of places, and there can be handshakes between your different phases of your products. We talked about the layers of machine learning, and I think those handshakes are really where things can go wrong.
Awesome. So I think with all of the hype of machine learning, I think as product managers, it's important to identify problems that are good for machine learning and not good for machine learning. So can everyone kind of share kind of your framework for how you think about classifying a problem as really good for machine learning and not?
I can take that. So echoing a lot of what people said, if you don't have data, you cannot start with machine learning products. So data is the core part. The second thing is thinking, as you said, whether we have opportunity for feedback mechanisms, being able to correct the data over time. If your product feature cannot incorporate that, you're going to spend a lot of time cleaning up your data. Another part is how okay it is for your product to be wrong. Systems are often wrong, and there needs to be some level of acceptance from the client to that. So those are all like products that are good to solve. On the flip side, I think that it's very important, specifically for us managing machine learning teams, is being really aware of what's the benefit of what we are working on. So benchmark what you're solving. So for instance, in the Gmail example that was brought before, if we know that only spam is only affecting 1% of emails, finding a machine learning system that does 95% correct classifications is not going to solve the problem, right? Because 99% of emails are just great. So really be sure that you're tackling the right problems and solving something, helping. The last thing I would say is that incorporate, if you need, you need to provide control. Sorry, I want to say control over, products that require you that users need to provide control are not going to work. So like coming back to my point earlier, sorry, if you cannot allow users to provide a feedback loop, then it's not going to work because you'll need to do the hard work yourself, or at least that's the way Google thinks about it.
Yeah, I'd say kind of related to your previous question too, one thing that surprised me was the lack of infrastructure for deploying, monitoring, and maintaining machine learning models in production. The tech just hasn't evolved yet, and so it's very nascent. And so by its very nature, I'd say machine learning models are less stable. As such, I'd highly urge people to look at other methods of classification and kind of cleaning and organizing data before considering machine learning. It's costly. There's no denying that, and so it should only be used when it can deliver kind of very much, not incremental value, but large-scale value.
Yeah, and going back to Sarah and Ronnie's point, you know, machine learning for us was really good because we were trying to automate something at scale. So we wanted to have conversations with tens of thousands, hundreds of thousands of customers and be able to deliver what they needed in real time. And so machine learning for us was perfect because it's able to sift through large amounts of data and classify it to an intent, which could be balance, what's my available credit, I want to pay my bill, things like that, and deliver exactly what the customer wanted to do. And also to Sarah's point, machine learning is not only very expensive, but it takes a really long time to build. And so if you're thinking about leveraging machine learning in your product, be really focused about what you want to accomplish. It goes back to the traditional way of, as a product manager, think about the customer problem first. Think about all of your options. Machine learning is one of them. And just be cognizant that, you know, it's going to take a long time to get there, but in the end, it's going to be great if you are very focused in the application.
Yeah, I'd say as product managers, we're all familiar with the shiny technology phenomenon, and machine learning is the latest shiny technology. Working with prospective enterprise customers, we see a lot of folks coming to us saying they want to do AI. You know, that's not gonna work. That's your approach. You have to have a business problem. So what is your problem you're solving? One way to think about the data is there are the sort of 4 V's of data that people talk about. There's the volume, the velocity, the variety, and then some people also add the veracity. So really thinking about, you know, can you trust this data is very important. Another type of problem that's good is really anything that's contextual, where you're getting down to that one-to-one experience with a user, end user, this sort of n=1 phenomenon. So I love that Carla brought up the 1,000 ways that customers can check their bank account.
Ask about their balance.
Yeah, exactly. Yeah. So that sort of contextual problem is very good. And then finally, a compliment to Ronnie's control point, which I really liked, is the sort of willingness to learn. So you have to be willing to learn.
Awesome. So given that machine learning is data intensive and takes a long time and is expensive, can some of you share stories of how you built a business case for machine learning, particularly Carla, you know, first U.S. bank to use machine learning and AI, you know, so there weren't any comparables like, oh, our competitors are doing this, we better do this now too. Just some stories of how you might go about building a business case for machine learning.
Yeah, sure. So a couple of proof points enabled us to get the buy-in to build Eno. So the first one is that we launched our Alexa skill about a year before, and we announced it at South by Southwest. We were the first bank to actually do that. And it gave us a lot of credibility, not only outside but inside the company around, hey, actually this is, the intelligent assistant space is a space where we should invest. Because as a bank, we have a lot of data about you as a customer, and we have the opportunity to kind of disrupt the industry by leading the pack and with some of these intelligent assistants. So that was one proof point. The second proof point is we didn't realize it, but we actually built like a rough prototype version of this chatbot. We actually have two-way fraud alerts that we send to you as a customer when there is a suspicious transaction on your account. And so the way it works is we say, hey, did you spend $500 at Nordstrom? Type in capital letters, confirm 6 or deny 7. And if you didn't type exactly what we asked you to, we didn't understand you. And what we found was not only were there failures in terms of, hey, actually, that's, everything's okay, or no, there's something wrong. 30% of the time, customers were actually asking something else. So they were asking, oh, I want to learn more about this fraud, or how did this happen? What are you guys going to do about it for me? And so we took those proof points and said, hey, there's an opportunity to deliver a much better experience through SMS, which is something everybody uses every day, and be able to understand our customers more than confirm 6 or deny 7. And so that is how we were able to get the buy-in to build Eno.
I guess from the venture perspective, very often there are, quote, AI-enabled machine learning, fill in your blank, companies that are trying to get buy-in from their investors. And the thing that we look at time and time again is are you using artificial intelligence to solve a real business problem? Is there a market need, or are you able to kind of use AI to deliver impact and value in a way that was not possible before? So if you are a trucking marketplace, you're a trucking marketplace. I don't care about the AI necessarily if you can show me initially that you're delivering value. That said, AI, ML, these things are IP, and they can help form a competitive moat. So I think Netflix is a perfect example. Netflix is arguably a media and entertainment company, not a tech company first, but they have created kind of phenomenal IP around machine learning and recommendations and clustering. And for that reason, it's pretty easy as an investor to justify their multiples. Sure, they can trade at 10x. So I would say that machine learning as IP, it does have value.
Yeah, and I guess this question is from both perspectives. So for Amy and Sarah, how do you navigate the build-buy decision? So Amy, on your side, you're trying to get people to buy your machine learning models and not use their own or develop their own and hire their own team. Sarah, you look at a bunch of different startups. You advise a lot of startups. How do you advise them on that?
I want to hear someone else answer this question so I can better advise my startup. So I will defer.
Right. So Clarifai, our company's value proposition / hypothesis is that it's very, very costly. It's been validated, as Sarah mentioned, to build your own model, right? So to get going with your own model, maybe you have, and maybe the problem that you're trying to solve is I want to be able to, for example, be alerted when my baby is around and awake from when the baby is in the crate versus when it's sleeping, for example. This is actually one of the projects that our data scientists implemented for his own child. So real life solution. So all right, I have this problem. It would be great. It will really solve my need of not having to go and check on my baby every 5 minutes, 15 minutes throughout the night. I can just be alerted on my phone or somewhere. If you wanted to go with build your own sort of solution here, you would need expertise. You would need to be a data scientist, which he happened to be one, but let's say, because machine learning and deep learning at its core is algorithm and data. Sure, you get your data from maybe your own baby cam that you've installed. How are you gonna build your own algorithm? Maybe you have the sort of IP as to how to build your own algorithm, how to sort of configure your own hyperparameters around all the different layers that you're going to set for your own sort of convolutional neural net, which is what we use. After that is you have to maintain it. So you need to pay for your own machine. Is it gonna run on your own sort of Apple Mac? Sure, maybe at a very low scale you can, but after a little bit you need to buy your own servers, right? And provide your own GPUs. And after that is, well, you probably want, and as a business scale, someone to maybe maintain and look after and monitor, the machines that you've just purchased. And so cost really does add up. And, it's usually not one data scientist. It's a team of data scientists who are continuing to sort of maintain. And once it's deployed, you have to keep on improving it so that maybe the baby grows and does different sort of tricks and whatnots, and you want to be able to maybe detect that the baby is up to something else other than sleeping and awake. So our hypothesis is that there is this shiny effect of like machine learning. We have to have our AI strategy. Let's build our own machine learning team. A lot of folks, I think, especially big companies, are sort of after that and building out their own maybe data science teams and structures. And for some of them, it makes sense, right? Like Carla was mentioning, it's very core to sort of the product that you're trying to build for your own customers. Then maybe it makes sense to make the initial investment and long-term investment as to maintaining and improving it and sort of growing with your product. If it's only really confined into sort of one specific need, you just need to be able to, at scale, address and classify this particular, type of data that's coming in, then it would be better to maybe go into the sort of a buy purchasing decision. But again, I would love to hear from you all as to how because obviously Carla, it seems like you're building on your own. Capital One is huge as a company, but anyone else want to chime in here?
Yeah, so I'll give the big corporation perspective. So the build or buy decision is really about, is this going to give you a competitive advantage to, compared to your competitors? And so us as a bank, we're still, I think, 5th or 6th. So we're not with the big 4. And so in order for us to keep that competitive advantage, we've really started investing in tech, really pushing that tech agenda, because we see that the future of banking is digital. And so we've made a ton of investments across the company, including we actually have established a center for machine learning, which is basically a center of excellence where anybody across Capital One, whether you're a business analyst, whether you're in tech or anything else, can learn about machine learning. So really, bottom line is this going to, one, is it a core to your individual product, but then is this going to give you a competitive advantage over time over your competitors?
Great, very insightful. So if we move to kind of the latter stages of product development, we were talking about building a business case and starting on machine learning projects. How do you think about measuring success of machine learning projects and machine learning models? And this question's for everyone.
Okay, so this is very Google perspective. I guess we touched on understanding the basically success of your system, and that's that is the metric that we use first and foremost. So we're talking about precision, we're talking about recall. Precision, we're saying, hey, how many times when you input the data to the system, it is correct. And being 95% of the time correct in most of our projects, it's enough. Us as product managers need to understand this target. Recall, on the other hand, says, okay, how many of our examples we can answer correctly, right? So if my system only works in the US for Google, it's okay, but it's not great, right? So this is the trade-off that we keep playing with. The other part that I would say for Google is also what's the user perspective towards that machine learning system. We don't want to create magic that is perceived as magic or perceived as freaky or scary. So we're very mindful about how people are interacting with it and are perceiving our features.
We had one concept at Mattermark too of errors that would flip the bozo bit. Like precision and recall, I think they're absolutely important, but you also have to have some notion of how certain errors impact customers. So if you're Amazon, like maybe you have a mistake where I'm looking at a vegan cookbook and you suggest some taxidermy to me. That's one mistake. Maybe it happens once in a month when I spend every day looking on their website, but that one mistake is enough to make me go to another vendor, to another e-commerce site. So I think it's not just kind of looking at some of these high-level metrics, but really understanding what makes your customers tick and what their sensitivities are to different error types.
Yeah, I think what's really tricky about machine learning is that these error measurements, when you're training your model, you're looking at how you're evaluating your model and you're optimizing your model. Sometimes those are different, but I think most importantly, you're testing on historical data that may be static, and it may not apply to what your actual use case is or what your business problem is. So if we look at really focused on what are you driving towards, and you need to be able to measure that in production. So it's very important that you're not just thinking about the test error, that you're also thinking about in production, how does my model perform against the incumbent approach that's currently there. So A/B testing, bandit testing is really important, and figure out what you want to measure from your business perspective, and then measure that in production, because you can't simulate that necessarily depending on the problem offline. We work with the federal government on event streaming detection. We also work with Procter & Gamble on recommendation systems, work with healthcare companies and airlines. They all have different business goals, and so it's important that you define those. One example from 2009 is the Netflix prize, which you may have heard of. So Netflix offered a $1 million prize for beating their recommendation algorithm. At the time, they were a DVD business. So the task was predicting ratings out of 100 items for users. So first of all, I think that there's a disconnect between, so what happened was there was a winner, but it was never implemented. It was never put into production. If you think about the task, it actually was not the best fit for the actual problem. So if you think about 100 items, a user is not going to go through 100 items. They're going to see maybe 7 when they're trying to choose a DVD. So one, there's a mismatch there. 2, they weren't necessarily thinking about the future and the future of their business. So they were transitioning from a DVD model with physical inventory to a streaming model, where there are also many opportunities to learn about the user, and the user can find new things, send signals in different ways, try to watch something and then stop, as opposed to just watching a DVD once. So it really didn't actually apply for Netflix to where they were going. So it was a $1 million investment that was very exciting for the machine learning community, but it didn't go anywhere for them as a business.
So something that you touched on, Sarah, around user trust. How, both qualitatively and quantitatively, how do you think about user trust? I think Something that you touched on with Amazon is these small edge cases that you might not realize would cause someone to churn and be offended or never come back and have a really poor experience. So how do you keep track of that, particularly with machine learning products?
Yeah, I mean, from an organizational perspective, I think one way of mitigating that is just having as much exposure to customers and potential customers as humanly possible. At Mattermark, I would often bring our ML developers to customer on-site visits, such, just kind of cultivating a high degree of empathy so that that's reflected in the product, I think is really important. But another thing that we talked about, and I think you had alluded to at Neurologic, is enabling interpretability. If you can explain why an error occurred or why you showed someone that taxidermy when they were really looking for vegan cookbooks, then it becomes a little bit easier to kind of move away from that mistake or to regain trust. It's hard with deep learning. Like, it's by its very nature a black box, but there are some kind of innovative ways of locally approximating some of the features that go into those models, at least. This all goes to say that I think when you can make your model as simple as possible, there are benefits because you do open up the possibilities for interpretation and explanation.
Yeah, to tag on to that, there are also like simple design principles that could help kind of bring that black box back to like tangible things, concepts that users can understand. So like coming back to the Amazon example, maybe one thing that they're actually doing great is saying to you, hey, people also buy those three items, right? It's probably not the only signal that they're using in the system, but they labeled it pretty nicely. They said this is like what people are commonly using together, buying together, and now it's becoming like someone else's problem. It's not longer Amazon's problem, right? So think about how you can actually build your product in a way that actually reduces the risk of antitrust or users not trusting.
So going deeper into the design aspect, we had a big hurdle to overcome with introducing an AI to like our wide consumers. So there's a lot of distrust around AI, like they're taking our jobs and all of this stuff. And so and like machine learning isn't 100% accurate. So we're gonna make mistakes. And so it's interesting, the approach that we took with Eno is I have a counterpart, Audra, who is the head of AI design, and she actually came from Pixar. And as we were developing this chatbot, it was equally important to develop a character. And so we went into this journey around, okay, what does, who is Eno? What does Eno represent? And as a part of that, we came to an agreement with, okay, we're trying to have a conversation with a human, but humans are so complex that we will never trick a human like with Eno. And so one of the character traits that we actually developed was Eno is a bot, and it's very straight up that it's a bot. And so as a part of our marketing and as a part of our character story and as a part of the conversation that Eno is having with you, it always reminds you that, hey, by the way, I'm a robot. I'm not actually a human, and I'm here to help you. So I'm going to get you the information that I need. But if a customer asks something that Eno doesn't understand, we have what we call graceful fails. So it's very important because the amount of things that you can do with Eno is a lot smaller than the amount of things that people will ask you. And so it's very important to have what we call graceful fails, where we tell the customer, hey, I didn't understand you, but I'm constantly learning, so keep talking to me. And so design for us was very important to overcome that hurdle that a lot of customers and consumers in general have around AI, and to keep encouraging them to use Eno even if Eno didn't work 100% of the time.
Actually, can I say? Yeah. So another point for those of you who work on personalization systems, making an interface that makes users feel like it's their responsibility to improve the system by asking them specific questions like, hey, are you you like this video, you don't like it? You're basically, which goes back to like feedback loop, right? But it puts the energy back to the user, and they feel responsible for correcting it, or responsible for the quality as much as we are.
Awesome. So a little experiment. Raise your hands if you've ever tried Spotify Discover Weekly. Ooh. It's pretty much everyone, most people. And keep your hands up, or raise your hands again if you think Spotify Discover Weekly really, really understands you. So a bit less. And so I guess raise your hands if you've experienced maybe a slew of bad playlists, and then you kind of churned and lost interest and said Spotify Discover Weekly doesn't really understand me. Yeah. So I hear that a lot. Like I love my Discover Weekly, but if I have a few weeks where I'm like listening to random things and I'm in a different zone, and then I come back to my Discover Weekly and it's got all these like new genres that I don't like, it's kind of like, well, you were optimizing for the wrong thing. You should have known that I was in this weird mood. But anyway, so it would be great if you could all share a little bit about your kind of product development process, maybe how you work with machine learning engineering teams, and then how you kind of think about timing and estimation.
Great. So I'd say that features of our product influence our product development process. Particularly, we're an enterprise software and we're a data product. So as I said, we have a lot of different types of customers. They all have the same software, but it has to be configurable for their use case. So we really have, for our user stories, really have these data stories. So what's coming to the system and how do we work with it, and how do we contribute, how does it contribute to the network? And in terms of projects with our enterprise customers, we ask that they have a cross-functional team so they understand, they make sure the right data is in there, they know the business, they have someone who knows the technology as well, so it's integrated well. And then internally, when we work on projects, it's very important to think about that deployment process and how you safely update the software across customers.
I think one thing that I mentioned to you, Inga, that I would highly recommend for companies, especially startups, to consider early on is actually having a VP level data hire. Ultimately, as we've all been kind of iterating, machine learning is costly, but you're competing for resources. Like, you're probably going to need a DevOps person or a data engineer who can help with deployment and data pipelining. And so you really need somebody at the executive level who can kind of help translate that company-wide strategy into a data strategy, and can also kind of help set things like data architecture and the associated technical debt fairly early as well. I mean, the other bit too is that I think a VP level data hire can create the right, and I hate this term, but the right kind of culture wherein people understand their career trajectory and how they relate to other divisions within the organization. So it may not seem intuitive. I would say, though, like, figure out if you need data science. If the answer is yes, make a VP level hire.
So at Clarifai, we actually have 3 different teams that are working on either the data or the algorithm portion of machine learning. So we have a data strategy team, which focuses on a lot of sort of processing and cleaning the data. It's the folks that will be sort of crawling and getting the right data or cleaning up the data that we get from our customers. We have applied machine learning team, which are consisted of machine learning data scientists or machine learning engineers, whose sort of focus is to work with research, which is sort of the third team, who works on sort of scaling and figuring out new algorithms to explore maybe and expand, new horizon within our sort of tech stack or our capability. And our applied machine learning team, in conjunction with the data strategy team, will be the ones to sort of supply the data that's needed to actually train the model and get the model to a good sort of production state so that we can ship. In terms of how to build a product and different process that we deploy, is I think the actually biggest thing that I've learned is to work with different types of engineers in this case. Not just back end, not just full stack, not just front end. We're working with data scientists. We're working with PhDs in, a convolutional neural net. We're working with, and also we're working with data strategists who sort of tend to be more junior and are very capable in sort of interpreting a problem into a visual sort of need, since we focus on computer vision, so that they can go find the right data. But it's learning to work with different types of folks and figuring out how to sort of draw the line as to when the model is ready, because a model can always improve. It will improve always with more data coming in, provided that the data is good. And I sort of look at all of these folks as more craft people. So they would want to really achieve the perfection, to go after the last sort of 20% or 5% or 1%. And as a product person, I need to be able to sort of take a step back and say, I think the model is ready to grab feedback from our customers. What do you think? And to be able to say, all right, let's get into the deployment mode and ship this. So that's sort of a different approach to shipping and building machine learning products. That's a little bit different from like a vanilla standard product, I would say.
And I definitely strongly agree with that. I had that experience at Automatic where I was also working with PhDs and machine learning engineers that were used to kind of producing machine learning models of really high accuracy, and they were really uncomfortable with shipping something much sooner and way less accurate. But from a product perspective, it made a lot of sense because we want to get user feedback. We want to see how this is actually performing, and if maybe it's good enough at the state that it is. It's not good enough to publish a research paper on, but it's good enough for a product. So I think that's a really interesting point. Sarah, go ahead.
Yeah, I mean, I just have to tell a kind of funny story that a colleague told me today, since you had mentioned your applied machine learning division. So this colleague went into a bank. He was meeting with their AML team, and he started going really deep into convnets and various other things. Realized maybe like 20 minutes into his presentation that he was talking to the anti-money laundering team. Of course, I got to have my really witty moment when I told him, know your customer. So.
So looking into the future, how do you think the machine learning landscape is going to change in the next 5 years, and how do you want it to change?
So I think that we are seeing more and more traction of machine learning, and I expect basically working at a company that really leads that conversation and changes its mission from like mobile first to machine learning first, to see machine learning really solving whole sorts of range of problems. We see it from what you mentioned before, like there are more funding in the area, there is more technology available for everyone off the shelf, great computational power and great algorithms to support a lot of the problems. So seeing it really as a revolution of the 2010s,